Hey guys, I'm at home today recording. Mad Eye Moody's helping me out apparently. I'm going to be talking to you about scatter plots today. We're going to be working with them a little bit in the next couple of days. Alright, so you need to write down everything that's in blue. The word objective goes on the left side of your Cornell notes and everything else goes on the right. So you're going to be able to read and create scatter plots. You're going to be able to identify positive and negative relationships in those scatter plots, and you'll be able to draw a line of best fit. It seems like a lot, and scatter plots are probably the most complicated kind of graph that we're going to be working with this time, but they're actually pretty easy, and you guys will be great. Alright, so a scatter plot is a graph that shows the relationship of two sets of data. That is the definition of a scatter plot. So always remember, with scatter plots, you're looking at two different sets of data, and you're seeing how they relate to each other, how one set of data affects the other set of data. You don't need to write this part down because it's not in blue. To find out how many pieces of data are in a scatter plot, you just count the dots. So here's our first example of a scatter plot. So the two sets of data are how long people spend studying, so how much time does each sixth grader at Live for Life spend studying, and then what was that person's test score. So you would ask the same people two questions. How long did you study and what was your test score? And then you would plot the relationship between those two on the scatter plot. So to have a scatter plot, you need to have a title, a key so that they know what the dots represent, the labels, the x-axis, which is always time. The x-axis is always time if time is one of your variables. If you're talking about time being one of the variables, it always goes on the x-axis. And then the y-axis here. Alright, so let's look at this example. So here's how you read a scatter plot. It's where the two meet each other. So go ahead and write this down. What was the highest score in the class? Well, to find that, okay, you look up here and see where the highest dot lines up. So the highest dot is right here, and it corresponds with 95. So they got a 95% for the highest score. Okay? How many students study for 1 hour? Well, what you do is you look at the x-axis label. It's time spent studying in hours. So you go to the 1 on the x-axis, which is right there, and you just see how many dots are exactly on that 1. 1, 2, 3, 4 dots are on that 1. So 4 students studied for exactly 1 hour. That's our answer. How many students scored above 75%? Well, what you can do here is draw a line at 75% for the test score and count the number of dots that you have above there. Let's see here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students scored above 75%. So this is showing how the test score relates to the amount of time people spend studying. Okay, so this is an example 2. This time spent at the mall and the amount of money left. Now what they're doing here, so basically they gave all these kids a certain amount of money and they said go to the mall for a certain amount of time, and we're going to count how much money you have left at the end. And then they gave you a table, time here, and money. So these are your two sets of data, okay? You asked everyone how much time did you spend, how much money do you have left. So first you have the title, you have your x-axis label, which is time, the y-axis, which is the amount of dollars left, okay, and then you start plotting. So the person who was there for 1 hour had $200 left. So you see the 1 would be right here on the x-axis, and it goes up to 200. And from there you just plot the rest. 3 hours, 155, so you'd be just above the 150. 4 hours, 145, just below that 150, and so on and so forth, until you've plotted them all together. So each dot represents where the two variables meet each other. And this is part of the reason why I had you guys do the coordinate plane activities before we did this. Just things to remember when you're reading or making a scatter plot. Choose a good starting and ending points for each axis. You don't have to write this down. Choose sensible scales. Make sure you're counting by the right amount. And time always goes on the x-axis. So I want you to go ahead and try this. You don't have to spend a lot of time on it, but pause the video and try to make a scatter plot based on the following sets of data. How much time people worked and how much money they earned. Okay, so review question. I want you to write this down. Why couldn't we use a pie graph or a bar graph, a circle graph or a bar graph for, I'm sorry, not the 2 homework problems, but for scatter plots? It's because you have to have 2 sets of data. Okay, with scatter plots, you have 2 sets of data. With pie charts, Circle graphs and bar graphs, you need one set of data. Okay, you're just asking someone how much time did you spend studying, and then you would have the bars for different people. Okay, you're not asking time spent studying, grade on the test, and where do they meet each other. Okay, so when should we use a scatter plot? When we're graphing two sets of data. All right, so we're going to be talking about the relationships you see on scatter plots now. The definition, a positive relationship, when you have a positive relationship on a scatter plot, it looks like the dots are kind of going up. In general, there's not always going to be a perfect line, but as the x increases, the y increases, okay? And it goes the other way too. If the x decreases, the y decreases. So driving time and distance. How long have you been driving and how far have you driven? The longer you drive, the farther away you've gone. Can you think of anything else that would go up? Two variables that would make each one go up. Let's see here. It could be something like the amount of time I spend running and how far I've gone. That kind of stuff. Okay, try to think of another example of a positive relationship. Okay, a negative relationship looks like the scatter plot's going down. It looks like the dots are kind of going down. And that means that the two x and the y values are doing opposite things. So the x increases and the y decreases. Or if the x decreases, the y increases. The x goes up, the y goes down, or the x goes down, the y goes up. All right, so the amount of time you've been driving and the amount of gas you have left is one example of a negative relationship. The more you drive, the less gas you have, okay? Try to think of another example of a negative relationship where one goes up and the other one goes down. Or that. All right, then there's when there's no relationship, the scatter plot just looks like there's dots kind of everywhere. You can't really see a trend. Okay, so it could be two things that just aren't related to each other, like your color, the color of your hair or your eyes or something like that, and your grades. They don't really have any effect on each other. Okay, I want you to write me another example of no relationship. Okay, so I want you to try this. Write down the ones in blue and then try to see if they would be positive, negative, or have no relationship. The time you spend in the gym and your strength, so the time you spend working out and how strong you are. Okay, if one goes up and the other goes up, then it's positive. If one goes up and the other one goes down, then it's negative. And if there's no relationship, then it's scattered, or there's no relationship. Okay, and then the second one is the amount of songs on your iPod and the amount of space you have left on the iPod. Okay, just write down whether you think that's positive, negative, or no relationship. All right, and then we're going to do really quick here a line of best fit. It's a line that summarizes the data set. So it's just a way for us to see if it's going up or going down. Okay, you don't need to write this part down. Just follow the basic direction of the data, the same amount of points above and below the line, and draw a line through as many points as possible. So here's an example. This is the time at the mall versus the money remaining. This is that one that we did earlier. How long have you spent at the mall versus how much money do you have left? When we draw a line of best fit, it looks a little something like that. Okay? It's going through a couple data points right here, and you have about as many on top as you do on bottom of the line. And you can see that this is definitely a negative relationship. The scatter plot looks like it's going down. Okay? So that means that the more time you spend at the mall, the less money you have left, which is definitely true for Ms. Zider. All right, we'll practice with this a little bit in class. You guys have a great rest of your weekend, and I will see you tomorrow.